Let us see Coulomb's law. In the year 1786, Coulomb deduced the force between two stationary point charges in vacuum or free space. Let Q1 and Q2 be the 2 point charges at rest in vacuum and are separated by a distance r. The charge Q1 experienced a force F12 due to the charge Q2, and similarly Q2 experiences a charge F21 due to the charge Q1. The force on Q2 exerted by charge Q1 is F21 equal to K into Q1 Q2 by R squared into R12 cap. R12 is a unit vector directed from Q1 to Q2 and K is the constant of proportionality. The force F21 acts along the line joining Q1 and Q2. Likewise, the force on Q1 exerted by Q2 is F12 equal to K into Q1 Q2 by R squared into R21 cap. Here the R21 and R12 acts in the opposite direction. So R21 cap, which is equal to minus R12 cap. Coulomb's law states that the electrostatic force is directly proportional to the product of the magnitude of the 2 point charges and inversely proportional to the square of the distance between them. Coulomb's law is analogous to Newton's law of gravitation. In SI units, K is equal to 1 by 4 pi epsilon naught, which is equal to 9 into 10 power 9 Newton meter squared Coulomb minus 2. Epsilon naught is the permittivity of free space or vacuum, which is equal to 1 by 4 pi K, which is equal to 8.85 into 10 power minus 12 C squared n minus 1 m minus 2. Therefore, F12 which is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared into R21 cap. We know R21 cap which is equal to minus R12 cap. So, F12 bar is equal to minus F21 bar. Therefore, electrostatic force obeys Newton's third law. Epsilon naught is the permittivity of free space or vacuum and epsilon is the permittivity in a medium. In vacuum, F21 bar is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared into R12 cap. In a medium, F21 bar is equal to 1 by 4 pi epsilon Q1 Q2 by R squared into R12 cap. Since epsilon is greater than epsilon naught, the force in a medium is always less than the force in the vacuum. We can define the relative permittivity epsilon r equal to epsilon by epsilon naught. So for vacuum or air, epsilon r equal to 1, and for other media, epsilon r is greater than 1. If 2 point charges of 1 coulomb are separated by a distance of 1 meter, then magnitude of F is equal to 9 into 10 power 9 into 1 by 1 squared, which is equal to 9 into 10 power 9 Newton. This value is a huge quantity, but in practice, in a day-to-day life, we use charges of the order of micro coulomb and nano coulomb. Thank you.